Your favorite intermediate algebra course. We're going to graph some simple rational functions. Not sure that simple is a great word for a title in mathematics, but anyways, let's look at the most basic rational function here. Y equals 1 over x, okay? So when you're doing these rational functions, what I would like to start out with is your vertical asymptote, okay? Your vertical asymptote. So think about, where is this thing undefined, right? You see that x in the denominator right there. You say, well, x cannot be 0. So you take that denominator, you set it equal to 0, and then you solve for x. Of course, this one's already solved for. And that's going to be where you are undefined, so at that value. So on your graph, you can say, all right, x equals 0. I'm going to have a vertical asymptote. I know I'm undefined there for any value of x being 0. Okay? And then you want to plug in some points to the left and to the right of that x value. So we had an x value 0, so I go to the right a couple, at least a couple, if not more, right? Go to the left a couple. Let's go -1, -2, -3. Anyways, enough until you're sure of the behavior of that function. And then we plug it in one by one. So here we go. 1 over x. So let's plug in a x value of 1. 1 over 1 is 1. Let's plug in an x value of 2 now. We got a half, right? Let's plug in an x value of 3. So y equals 1 over x. X now being 3, 1/3. Let's plot those. 1, 1, 2 comma 1 half, 3 comma 1/3. And if you think about it, 4 is going to be a fourth, right? 5 is going to be a fifth. So to the right, you can see this thing is going lower and lower and lower, right? So as we shoot out to infinity, we are approaching a y value of 0. So we're going to have this horizontal asymptote. We now also have a horizontal asymptote at y equals 0. So you can make note of that. As you shoot out to an extremity, you're approaching that y value of 0. You never touch it. Okay? Now let's go between 0 and 1 before I go to the left here. So, like, let's plug in a half. All right? Let's plug in a half for x. So we can see what's going on in here, right? Between 0 and 1, if you will. So y equals 1 over x, 1 over a half. Of course, we go ahead and simplify that. Now we got y equals 2, right? So when x is a half, we're up here at a y value of 2, right? In fact, let's go right between 0 and a half. Let's go a fourth. So 1 over 1/4, which would spit out 4, right? A fourth of the way. I'll clear up here a 4. Anyways, you see how this thing is kind of shooting up there? So as your x value goes towards, you see how as we go towards 0, this thing shoots way up, doesn't it? The closer I get towards 0, the further up my y value ends up being. Okay? All right, now let's go to the left here. So let's pick some y values to the left of that vertical asymptote. So -1, -2, -3, and so on. We plug those in. 1 over x. X is -1, so 1 over -1, -1, right? 1 over x. Now I plug in -2, so we got -1/2. 1 over -3, -1/3. Let's look at those. So -1, -1, right? -2 comma -1/2. -3, I'm down a third of the way. -4, I'm only down a fourth of the way. Anyways, you can see this. Plug in -1/2. 1 over -1/2 is -2, all right? So you'll have that point as well. You can kind of see how this thing shoots down, doesn't it? Okay? So there's the old rational function 1 over x, the classic parent function. Okay? Let's talk about our domain here. What would the domain of this function be? X such that. You see how all x values are encompassed except for that vertical asymptote. You see how we'll never hit that x value of 0? So x is all real numbers except for 0, right? We never hit that. Okay? and then our range here, the lowest, you notice that it shoots way down low, our Y values. So we're like, yeah, all these Y values are good to go, and then we stop right there at that horizontal asymptote. We do not hit that horizontal asymptote of Y equals 0, do we? So we say the only interruption in our Y values is at 0. Okay, so all real numbers except for 0. Now we're going to have some transformations of this. Okay, so that's your parent function here. That was bugging me. All right. So let's say we have y equals 3 over x minus 2 and plus 1. Now you notice that plus 1 on the end. Let's think about the transformation before we even start plotting this thing. That plus 1, that's going to be a vertical shift, right? And is it going to go up or down? And you say, well, it's plus 1. This one's vertical shift up 1 unit, right? That's a rigid transformation there. Now you notice the x minus 2. Remember that horizontal shift? The horizontal shift is kind of counterintuitive. This one's actually going to be a horizontal shift to the right, too. Okay, so horizontal shift right, too. So think about your transformations. You still got that constant on top there, except it's a 3. So that's going to change a little bit. Some things on your rational function. So we're just going to start plotting this thing as well after we get our vertical asymptote. So let's start. Let's start with our vertical asymptote. You notice your denominator there. You notice that x minus 2. You want to figure out where is this thing undefined, right? In other words, where's x minus 2 equals 0? And you solve that. You add 2 to both sides. You say, oh, okay. If I have an x value of 2, this thing will have a 0 in my denominator, right? In other words, we're undefined. So I go to my graph. I put that vertical asymptote on there. I say I'm never going to touch that x value. Okay. And then we're going to go from there. And you notice this thing has been bumped up 1, hasn't it? It's been bumped up 1. So the former horizontal asymptote of y equals 0 has now been bumped up to y equals 1. Okay. So you have this horizontal asymptote having been bumped up 1. Okay. And you would see that if you start plotting some points here. So let's plot some points. Okay, so I'm going to go to the right a few of my vertical asymptote. So let's go 3 and 4. See what that gives us. Let's start out there. So here's my equation, 3 over x minus 2 plus 1. We're plugging in 3 first for x. So we got 3 over 1 plus 1, so it ends up being 4. Y is 4. So 3 comma 4, plot that. 3 comma 4. Plug in 4 now. 3 over 4 minus 2 plus 1. So we got 3 halves plus 1, which is 2.5, right? 1.5 plus 1. So 2.5. So 4 comma up 2.5, right? If we could keep going as far as you wanted to go, maybe we'll go another one here, 5. So we got 3 over 5 minus 2 plus 1. So 3 over 3 plus 1, so we got 2. 1 plus 1. So 5 comma 2. Anyways, you get enough of these and you're like, okay, yeah, I can see I got this curvature here on this rational function. Okay. Now you want to go to the left of the vertical asymptote and get some points to the left of, and you notice our vertical asymptote was at x equals 2. Okay. So we're going to pick an x value to the left of 2, so an x value of 1, maybe an x value of 0, maybe an x value of negative 1, as far as you feel comfortable going, or at least until you see it and you can see the behavior of this function. So 3 over, we're picking 1 to be our x, so we got 3 over negative 1 plus 1, so we got negative 3 plus 1, which is negative 2. So 1 comma negative 2. Okay, now we're plugging in 0. Plug in 0 now for our x. So we got 3 over negative 2. So we got negative 1.5 plus 1. Negative 1/2, right? Negative 0.5. So 0 comma negative a half right there. Let's go one more. How about negative 1? Y equals 3 over negative 1 minus 2. So 3 over negative 3 plus 1, which is negative 1 plus 1, which is 0. So negative 1 comma 0. You could obviously get some more points, but you kind of see it right there, don't you? Okay, there's the graph of our rational function. Okay, now the domain here. You notice, so you're looking left to right, aren't you? Okay, so you're like, well, it keeps that going way out to the left. You know, it's all it's all on here. All these x values are on here. They're all defined in this area. And then you have this interruption, don't you? You can see this, right? It's all on there, but you have that interruption of the vertical asymptote. So with the exception of the vertical asymptote, your domain is all real numbers. So all real numbers except for you're not going to hit that x value of 2 because that's where it is undefined. Okay, it causes that to have a denominator that's 0. Right, if you were to plug 2 in right there, it'd be problematic. Okay, your range, so you're looking how low does this thing go? It keeps going way low, right? Way low, way low, way low, 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 and it's all on here, right? And then you're like, wait, what's your y value stop at? A y value of 1, so it does not hit that horizontal asymptote. So you have y such that all real numbers except for 1. Okay. Y is an element of all the real numbers except for 1. Okay, you'll never hit that horizontal asymptote in this case. Okay, so that's our second rational function. All right, let's look at another one here. Y equals 4x minus 2 over 2x plus 2. Okay, you can either leave it in that form right there and start graphing it, or if you'd like to, you can also divide this and you probably see the transformations easier because you notice you have an x value there on top. So if you did, here's another form of it. 4x plus 2, do the long division on this one. 2x plus 2. Trying to match that 4x, right? So you say what times the 2x gives me the 4x, right? If you remember the old long division section. You say, well, it's 2. And you multiply it. 2 times 2x, 4x. 2 times that 2, 4. Don't forget, change your sign. Okay? 2 minus 4 is a negative 2. So your answer is quotient 2 plus remainder over divisor, 2x plus 2, okay? And usually, as a rational function, we would write it this way, plus the 2 on the end. And this is our other form of this. So let me write it the other form as well. And that might help you see, whoops, plus 2. Drop my eraser. Okay, so there's the other form of that thing. So you can say, well, this is going to shift that thing up too. So I'm going to have a horizontal. That's going to cause my horizontal asymptote to be y equals 2. Right? It's going to bump that up too. And you'd see that probably if you plug some points in, right? And then you want to think about your vertical asymptote. Okay, where's your vertical asymptote? So you take that denominator and think about where's that thing undefined. Solve that, subtract 2 both sides, now divide by 2, and I say x equals negative 1. So negative 1 is where I have this vertical asymptote. Okay, so I have a vertical asymptote, negative 1. I have that horizontal asymptote at y equals 2 because I was shifted up 2, wasn't I? Okay, and now we're going to plug it in. Okay, and you know, I'm going to go back to, I like this equation for simplicity when I plug stuff in. Okay, and I plug stuff in to the right of my vertical asymptote. So my vertical asymptote is at negative 1. So I'm going to go to the right of that, 0, 1, maybe 2, as far as you want to go. And then I'll go to the left. Okay, so let's plug 0 in first. 4 times 0 minus 2 over 2 times 0 plus 2. So that ends up being negative 2 over 2 or negative 1. So 0 comma negative 1 right there. Okay, plug in 1. Plug in 1 now. So we got 4 times 1 over 2 times 1 plus 2. So we got 2 over 4. So we got a half. 1 comma 1 half is our point. 1 comma, I'm up halfway. Let's go another one. How about 2? Let me erase this. So we got 4 times 2 minus 2 over 2 times 2 plus 2. 6 over 6, we got 1. Okay. So we plugged in 2 and it spit out 1. Anyways, we could keep going on this, but you probably kind of get the feel for this rational function. It kind of behaves like our 1 over x with the curvature there. Okay. Now we pick some points that are to the left of our vertical asymptote. Okay, again, our vertical asymptote is at negative 1, so let's pick some to the left. So negative 2, negative 3, negative 4, enough until you feel good about things. So 4 times negative 2 over 2 times negative 2. So we got negative 8 on the top minus 2, negative 10. On the bottom we got negative 4 plus 2, negative 2. So that ends up being 5. So negative 2 comma 5 is a point we'll put on there. Let's do the negative 3 now. So we got 4 times negative 3 over 2 times negative 3. So negative 14 over, what's that, negative 4. Extend that a little bit. There we go. So 7 halves or 3.5. Okay, let's do the negative 4 now. So negative 4 I'm plugging in after I erase this stuff. So plug in negative 4, I got negative 16 on the top, minus 2, negative 18. Plug in the negative 4 on the bottom, I got negative 8 plus 2, negative 6, so I got 3. Okay. Alright, put those points on, go up a little bit. So I got negative 2, 5, negative 2, 5, negative 3, comma 3.5, negative 3, I'm up 1, 2, 3 and a half. 3.5, I got negative 4 and I'm up 3. 3, and you can kind of see staying within our vertical and horizontal asymptotes here. Okay, and finally let's talk about our domain and range here, and we'll call it good. So our domain here is going to be all real numbers except for that interruption by that vertical asymptote. So x cannot be, our vertical asymptote was negative 1. Okay, our range is going to be, you notice it just has the interruption in the y value of 2, so y cannot be 2. Okay, and there's our domain and range. Happy graphing. We'll see you guys in class.